Our primary demo involves scheduling appointments. Appointments have a start and an end time. These two things always go together, so they make sense to extract as a value object. Here's a closer look at the DateTimeRange value object we created for the course's demo. We also have a DateTimeOffsetRange, which is identical but includes support for time zones. Because DateTimeRange is a pretty low-level concept that could be useful in a number of different applications, it's implemented in the shared kernel package. The class inherits from a value object base class that provides flexible equality checking behavior, so we don't need to clutter our class with overloads for equals, get hash code, etc. It was written by fellow author and DDD expert Vladimir Khodorkov.
Because this is a value object, you can see that all of its properties are read-only. Recent versions of C# and Entity Framework Core do allow us to avoid even having a setter in there when we want to define read-only properties. And we also now have the use of records in C#. EF Core can comprehend read-only properties that don't have any setters at all, and it takes advantage of fields. But here, we've written our value objects in a more generalized way that's not taking advantage of any specific or specialized features. However, you can adapt these samples to benefit from those specific APIs and language versions that you're working with. The important goal here, though, however you implement it, is that the state of the value object should not be changed once it's been created and is part of the domain model.
Right. Value objects should get all of their state through their constructor, and any invariants that need to be checked should happen in a constructor as well. In this case, the DateTimeRange is guarding against having a start time that exceeds its end time. If it does, an exception will be thrown. The second constructor that takes a time span calls the first one using constructor chaining, so in either case, the guard will always be enforced. Since the DateTimeRange is immutable and cannot be created in an invalid state, the rest of the domain model can count on it being valid.
Our DateTimeRange type does have some additional methods that let us create new DateTimeRange instances from existing ones, much like the DateTime type provides options to create new date times by adding time to an existing instance. In our type, for example, to change an appointment set to end at 10:30 instead of ending at 11, a new instance of DateTimeRange can be created using the newEnd method. Finally, the base value object class requires overriding a getEqualityComponents method. This is used when comparing two instances of the value object, and it's up to you to decide which properties should or shouldn't be included. In the case of DateTimeRange, the start and end times are sufficient. If two DateTimeRange instances have the same start and end values, they should be considered equal.
Custom logic needed to determine whether one appointment overlaps with another is another area where the value object can help. The whole appointment isn't needed to determine if there's an overlap in appointments. Only the DateTimeRange is used in such a calculation. Thus, the overlaps method shown here has been moved out of the schedule and appointment classes and into the value object, where it is more reusable and it reduces the complexity and responsibilities of the other domain types.
We asked Eric to share his thoughts on moving logic out of entities into value objects. He agreed that it's a good idea. What he said was, if there's logic that's really the classic software logic, I like to add that in value objects. You can really test value objects much easier than entities, and you can use them much more freely. So your entity becomes this critical piece of glue, an orchestrator among different value objects. But that doesn't mean that you won't have some logic in the entity. It'll just be very concise.
Eric also said that it's a nice way to work towards the ubiquitous language, to the point where you look in the methods of the entity and you see higher level things. They read like use case level communication, rather than nitty-gritty detail. My personal takeaway from this is to keep an eye on the properties of your entities, and specifically their types. If you find that they're all primitive types, like ints and strings, think about if any of those primitive things could be grouped together as value objects instead. Another value object that we can point out here is the animal type. This is just to give you an idea that our value objects can be extremely simple. In this case, animal type is just a combination of the species and the breed of a particular pet or patient that we're dealing with at the vet clinic. And there's not a whole lot of other behavior here, but it does provide us with a container by encapsulating these two related properties together as a single value object.
When an operation is important to the model but doesn't necessarily belong on any one entity or value object, a service is often appropriate. But don't be too quick to give up on finding a natural home for the operation on an existing entity or value object, or you may end up with a very procedural, anemic model. Frequently, domain services serve as orchestrators for operations that require several different collaborating entities or value objects. Evans notes that good domain services must first and foremost not be a natural part of an existing entity or value object. Again, we don't want to shift all of our rich behavior from our entities and value objects to our services. Services should also have a defined interface that's comprised of domain model elements. And finally, domain services should be stateless, though they may have side effects. What this means is we should always be able to simply create a new instance of a service to perform an operation, rather than having to rely on any previous history that might have occurred within a particular service instance. But of course, the result of calling a method on a service might result in changes to the state of the system itself. These rules apply specifically to domain services, which belong in the core of our application. Your software will likely also use services to perform work related to infrastructure or as part of the front end of the application.
Here are some examples of the kinds of services we might find in different layers of a DDD application. The UI layer represents the front end of the system and should have as little business logic as possible. It is frequently combined with the application layer, which should be concerned with behavior necessary for the application but unrelated to the customer's problem domain. For example, the application may need to work with file formats or parse some XML, and it might have services for these purposes, but these are unrelated to the domain. In the core of the application, where we store our core model and domain objects, we will define any domain services for operations that don't belong somewhere else. These services will frequently involve operations on multiple domain elements, or may be responsible for orchestrating some kind of workflow. For instance, processing an order might involve a series of steps and multiple domain elements as the system checks inventory, verifies customer information, maybe charges a credit card, and then sends messages to ship the order, notify the customer, and reduce inventory. Finally, we have infrastructure-level services. These will usually implement interfaces that are defined in the core of the domain, such as I send email. But since they require access to external dependencies like file systems, databases, or network resources, they live in the infrastructure layer of the system. With respect to our domain, you may find infrastructure not very interesting,
although the people who create the internal workings of those services might find them quite fascinating. We'll look at implementing services in our application later on in the course. Let's review some of the important terms you learned in this module. You heard us talk about immutability, which is a really critical attribute for value objects. And immutability just means once an object has been instantiated, you can't change the value of any of its properties.
Another important term we learned about is the value object. A value object is an immutable class that is defined by the sum of the different properties that it has. We don't need an identity for a particular value object. In fact, a value object doesn't have any identity outside of the individual properties that it has. And in order for us to compare value objects, we simply compare all of its properties, and if they all match, then we can consider these two value objects to be equal.
We also learned about domain services, and these are interesting because domain services give you a place to put logic and behavior that you can't find a home for in the entities and value objects in your domain.
And the last term that we want to review is side effects. Side effects are changes that occur in your application or any kind of interaction with the outside world. Now, technically, any change to the state of the application can be considered a side effect. But generally, when we're talking about them, we're talking about things that changed other than the main intent of the operation that you're performing. For instance, it's often a good idea to keep operations that query information separate from those that change state. And if you follow this practice, then any queries that you make that result in changes to state would be said to have side effects.
That brings us to this module's key takeaways. Most of this module was focused on value objects, which are used in your domain model to measure, quantify, or describe something in the domain. Value objects typically don't exist alone. They're usually applied to an entity to describe something about it.
Value objects should be compared using only their values. They don't have an identity. Any two value objects that share the same values should be considered equal. And value objects in our domain should be designed to be immutable, taking all of their needed values in their constructor. And they shouldn't have any side effects.
We looked at a few examples of value objects in this module. We mentioned the .NET Framework string type that you've no doubt used. Strings and datetimes are value objects that are available to any .NET application and can be used as a model for how you should design your own value objects. We also looked at a couple of custom value objects we used in our sample application, the datetime range and the animal type objects.
Finally, we wrapped up the module by introducing domain services, which are used to orchestrate operations between different parts of your domain model. Remember that domain services should generally only be used if you don't have an entity or value object where the behavior makes sense. Overuse of domain services can lead to an anemic domain model. In the next module, you'll learn how to build aggregates from entities and value objects while respecting their relationships. Here's some links and resources relevant to the topics of value objects and domain services that we discussed in this module. Thanks for watching Domain-Driven Design Fundamentals.